Okay, welcome back. Let us now move on to page 5 of our same set of notes. Let's try and understand the question. We've got ABCD is a parallelogram. AB is 6, so that tells us that DC is also 6 cm. And they further tell us that area of the triangle ADE is 3/4 of the area of the parallelogram. So ADE and ABCD, we are comparing these two. What do they have in common? Let me highlight the triangle. ADE is our triangle versus our parallelogram ABCD. ABCD. Okay, so what do these two shapes have in common? By observation, they share the same perpendicular height over here. This will be the key to finding the relationship between their two areas. Let's call this H. Okay, so just for your notes, triangle ADE and our parallelogram ABCD share same perpendicular height. So we let H be perpendicular height. Now let's write down the area of triangle ADE, because that's what the question said. Area of triangle ADE they said that it is 3/4. It is, so equals to 3/4 area of ABCD. This is what the question is telling us. We now convert it to our mathematics. So triangle area will be half times the base. The base is AE, which we currently don't know yet, and we multiply by our H, the same perpendicular height. And this has to be equal to the 3/4 of the area of ABCD, which we know by now. Cut out the triangle, put it on the other side, form a rectangle. Base of the rectangle is 6, and it has the same perpendicular height as our triangle. At this point, we are happy to see this because we can divide both sides by H. It doesn't matter what H is. They're going to be the same. We're going to divide them away. Okay, now we want to find from here we are able to eventually get our AE value, because that's the only unknown now. So let us get rid of the half. We are going to multiply both sides by 2. So the half disappears. Now we end up with AE equals to, take out 3/4 times 6, and then you multiply by 2. You will get 9 cm. So the whole portion here, 9 cm. And that makes it really easy to find the length of BE now, because BE is going to be 9 minus 6, which is left with 3 cm. Exercise 6. So take a pause here first. Look at the question, try it yourself, and then unpause the video. So given that you have attempted ABCD with the parallelogram again, BC given to be 12, check your diagram matches with the question, and then they tell us that area of triangle ABE. So here's our triangle. Is 1/5 of the parallelogram ABCD. Find the length of BE. Does the question look familiar? It should lah. So that tells us that this is an important skill that you must pick up from here. Same thing. In the previous question, we saw they share the same perpendicular height. Will it be the same here? For the green triangle, for the yellow parallelogram, is there a perpendicular height that is the same for both? So it turns out, for the triangle, there are 3 options for your perpendicular height with the corresponding base. If this is, if we choose this as a base, then this will be the perpendicular height. But it is not the perpendicular height of the parallelogram. So no, we're not going to choose that. If we choose this as the base of the triangle, then the perpendicular height is here. But it is clearly not the same perpendicular height of the parallelogram. We're not going to use that. That leaves us with choosing this as our base and the perpendicular height. You will need to extend it, drop a perpendicular down. This distance being our h, it is the same perpendicular height as our parallelogram with the base 12. Okay, so this is what we're gonna use. So in our mind, you don't need to write this down. In our mind, you know that triangle ABE and our parallelogram ABCD share same height, rather the same perpendicular height. So let us write down our working already. Let perpendicular height be h. And now we carry on with the question. They say area of triangle ABE. Let's write that down. Half times the base of ABE. This time we selected BE as our base of the triangle. Times the perpendicular height. We don't know what that is. Let's just call it h. They further tell us that is 1/5 of the parallelogram. So is 1/5 area of the parallelogram. We're going to choose 12 as the base. And the perpendicular height, again, it is the same h. Our objective is to find the length of BE. So looking at our working, we want to get rid of the half. We want to get rid of the h. We do so by multiplying by 2 on both sides first. Then we can also divide by h on both sides. That now leaves us with BE will be 1/5 times half times 2. So 24/5. That is 4.8. Okay, so this is something for you to think about. Try. Let's move on to the next page. Okay, this time we have a rhombus. Rhombus is a 4-sided figure that is actually a parallelogram. Okay, so these are the properties which we have covered previously already. So yes, it is a parallelogram. What is the reason? It satisfies all properties of a parallelogram. But the other way around, is a parallelogram a rhombus? Not all the time. Not all the time. Sometimes it is. Sometimes it is not. So what is the reason? Well, give a counter argument. A parallelogram, a parallelogram may not have 4 equal sides. If it has 4 equal sides, then it's a rhombus. But sometimes it doesn't have 4 equal sides. So you just stay as a parallelogram. Okay, so now let's see how is there another way to find the area of a rhombus. The answer is here. Turns out it is the half of length of the first diagonal times the length of the second diagonal. Let's see why this works. Rhombus number 1. Let us try to cut this rhombus into 2 triangles. And you can see by symmetry, triangle on top, ADC, is the same triangle as ABC. So information provided, AC is 16, So this distance here 16. They provided dB is 10. So this portion is 10 cm. Let us try to find the area of the triangle on top. So area of triangle ADC, half times the base, which is 16, times the perpendicular height, which is 10 over 2. So we can get a value, 5 times 8, we get 40. But you notice that the area of the triangle below is the same. So our area of rhombus ABCD must be 2 times of 40 to give us 80 square centimeters. Okay, so that is how you can find the area of a rhombus. But what if we want to attempt using this formula, or even better, you're wondering why does this formula work? Let's try. Again, in rhombus number 2, we have 2 triangles, right? And they are the same triangles. Information given, we've got AC to be 8 cm and DB to be 12 cm. Let's put it all in one step. So area of ABCD is going to be 2 times of half times the base times the height of one triangle. So our base, let's use 8, and the height we have 12 over 2. So that gives us 8 times 6 to be 48. So where does that highlighted formula come in? I'll show it to you. 8 is a diagonal. 12 is another diagonal. Let's see what happens to the 2 over 2. Both of these will cancel, right? So what does that leave us with? That leaves us with, running out of colors to choose. That leaves us with, let's go with purple. This portion, half. This is our diagonal. Let's call it the first diagonal. And this is our diagonal number 2. And that's where the formula comes from. We don't need to go through this long working if you memorize the formula. But if you forget the formula, don't worry, it is just made out of 2 triangles. So let's attempt to find the area of this rhombus using the formula directly. Half times the diagonal, first diagonal given to be AC 4 cm, second diagonal given to be 16. So 2 times 16 gives us 32. So the area of rhombus, our summary is half times diagonal 1. They listed the diagonal, the first diagonal to be A, the second diagonal to be B. So that makes it easier for us to write half AB.